Hello there, and welcome back to the Sleep Science. You arrive gently without needing to pack anything into a version of the universe that feels familiar at first. Solid, dependable, quietly humming along the way it always has. You picture the room you're in now, the weight of your body resting somewhere soft, the faint sounds that leak in from the world outside. Everything seems certain here. A floor is a floor, a wall is a wall. But as you breathe slowly, you begin to drift inward, downward, into scales so small they stop behaving like anything you've ever touched. You imagine shrinking, not dramatically, just gradually, as though the universe is politely zooming in for you. Molecules come into view, then atoms, once thought to be the smallest indivisible pieces of matter. And a mainstream scientific fact settles in calmly beside you. By the early 20th century, physicists discovered that atoms themselves are mostly empty space, with tiny nuclei surrounded by restless electrons. Even knowing this, it still feels strange. Empty space pretending to be solid. You probably won't survive this with your eyes open. As you continue drifting, the rules you grew up trusting begin to soften. Objects no longer have precise edges. Locations feel more like suggestions. Down here in the quantum world, reality whispers instead of announces itself. Particles don't quite exist until they're asked to, and even then, they answer in probabilities rather than certainties. It's less, this is where it is, and more, this is where it might be. My statistically speaking. There's a quirky detail tucked into this strange place. Some physicists casually refer to virtual particles popping in and out of existence as the universe briefly borrowing energy from itself. Like a cosmic credit card swipe, it promises to pay back immediately. No receipt, no record, just a fleeting flicker of something that technically shouldn't exist, yet does. It's oddly comforting in a way, like the universe admitting it improvises sometimes. You notice the silence here isn't really silent. There's a constant underlying vibration, a low-level buzz known as quantum fluctuations. Even in a perfect vacuum, things are still happening. Motion never fully stops. Absolute stillness turns out to be an illusion we enjoy only at larger scales. One historian still argue whether early physicists truly understood the implications of this discovery, or whether they simply opened a door they couldn't close again. As you float, you realize how this tiny realm governs everything above it. The chair supporting you, the air moving in and out of your lungs, even the soft glow of a screen, all of it relies on quantum behavior quietly doing its job. You don't need to understand the math. You don't need to solve anything. You're just here to notice, to let the strangeness wash over you without resistance. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like it, leave a comment telling me where you're listening from and what time it is there. Somewhere in the world, it's always night. Now, why dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift a little deeper still, letting go of the expectation that reality must make intuitive sense. Down here, it doesn't owe you that. And strangely, that's exactly what makes it peaceful. You continue drifting without effort, as though the universe itself has taken over the navigation. There's no sudden drop, no sharp transition, just a gentle sense that the rules you once trusted are loosening their grip. Up in the everyday world, you expect causes to lead cleanly to effects. You flip a switch, a light turns on. Simple. Down here, that kind of certainty feels a little overconfident. You begin to notice that nothing is pinned down the way you're used to. Instead of firm answers, you're offered ranges, likelihoods, one soft maybes. This is where probability replaces certainty, and it does so without apology. A mainstream scientific fact drifts past you like a slow-moving cloud. In quantum mechanics, particles are described by wave functions that don't give exact positions or speeds, only probabilities of finding them in certain states. Reality, it turns out, prefers odds to guarantees. You imagine rolling a die, but instead of landing on one face, it somehow lands on all of them at once, at least until someone looks closely. It sounds absurd, and it kind of is, but that's the logic operating here. The universe doesn't commit until it absolutely has to. And even then, it does so with a shrug, as if to say, This was just one of the options. There's a faint comfort in this softness. Certainty can be exhausting after all. Always having to be something, and always having to be somewhere specific. In the quantum world, things are allowed to hover, to be undecided, to exist as a spread of possibilities rather than a single rigid fact. If particles can live like that, maybe you can too, at least for the next little while. A quirky tidbit floats by. Early critics of quantum theory jokingly accused it of turning physics into glorified gambling. One famous physicist grumbled that the universe shouldn't be left to chance, as if reality had made a poor career choice. And yet, here we are, in a cosmos that rolls its quantum dice constantly, with remarkable consistency. You sense that probability here isn't about ignorance, not about missing information. It's baked into the fabric of things. Even if you knew everything that could possibly be known, uncertainty would still remain. And that realization lands softly like a pillow placed over the need to control outcomes. Historians still argue whether the founders of quantum theory truly accepted this randomness, or whether they spent their lives quietly hoping for a deeper, hidden order beneath it all. As you drift, you notice how this probabilistic nature doesn't lead to chaos. At larger scales, all those tiny uncertainties average out into stable patterns. Tables remain solid, planets keep their orbits, coffee generally stays in the mug. The unpredictability is real, but it's gentle, contained, almost polite. You breathe in slowly, imagining each inhale as a cloud of possibilities, each exhale as the universe calmly selecting one of them. There's no rush, no pressure to collapse into a single outcome just yet. You're allowed to exist in between, awake and drifting, when listening and letting go. And as you settle into this blur between what is and what might be, you realize that certainty was never the thing holding everything together anyway. Probability has been doing that job all along, quietly, patiently, while you rest. You drift onward, still carried by that soft sense of maybe, when you begin to notice something subtle and constant. Nothing here is ever truly at rest. Even now, as you lie still, feeling pleasantly heavy and calm, the smallest pieces of you are impossibly busy. Down at this scale, stillness is more of a polite fiction than a real condition. You focus on a single particle, anyone will do, and try to imagine it pausing just for a moment to catch its breath. It never quite does. A well-established scientific fact settles gently into your awareness. According to quantum mechanics, your particles always retain some motion, even at absolute zero temperature, a consequence of what's known as zero-point energy. The universe, it seems, refuses to let things completely switch off. This constant motion isn't chaotic flailing. It's more like a quiet restlessness, a subtle hum beneath existence. Electrons don't orbit nuclei like tiny planets, despite how the diagrams looked in school. Instead, they exist as fuzzy clouds of probability, always moving, always shifting, never pinned to a neat path. It's less like a racetrack and more like a dream, where locations blur into one another. You might find it oddly reassuring that even in perfect cold, with all thermal energy stripped away, there's still movement, as if the universe itself can't help but fidget. A quirky detail drifts past. Some physicists jokingly describe particles as being unable to sit still because the universe doesn't provide them with chairs. It's a silly image, but strangely fitting. Cosmic restlessness as a basic feature of reality. You realize this motion isn't driven by anything external. No invisible hand is shaking the particles to keep them awake. Their movement arises naturally from the uncertainty built into existence. To know exactly where something is would require it to stop completely, and the universe simply doesn't allow that. Historians still argue whether this limitation reflects a fundamental rule of nature or merely the boundary of what measurement itself can achieve. As you float, you notice how this perpetual motion connects to your own experience. Thoughts drift even when you're trying to rest. When sensations rise and fade without permission. Complete mental stillness is just as elusive as absolute physical stillness. Maybe that's not a flaw, you think, but a feature. The idea that motion never stops might once have sounded exhausting. But here, in this slow descent towards sleep, it feels gentle. The movement is tiny, unobtrusive, almost like the background hum of a fan or the distant sound of traffic blending into white noise. It's not demanding attention, it's simply happening. You imagine the universe as a place that's always quietly alive, even in its calmest moments. No dramatic action, no sudden jolts. Just a soft, endless stirring that keeps everything from freezing into silence. And somehow that makes rest feel safer. The universe isn't going anywhere. It's awake enough to keep things running so you don't have to be. When you let that thought settle, allowing your own restlessness to soften rather than disappear. Down here, nothing ever fully stops, and that's okay. You don't need to either. You're free to drift, carried along by motion so small it feels almost like stillness. You continue drifting, carried by that gentle, unstoppable motion when something curious begins to happen. The particles around you seem to lose their sharpness. Edges blur, shapes soften. What once felt like solid points now stretch out, spreading themselves thin like mist in early morning air. This is the place where waves pretend to be things, and things quite convincingly pretend to be waves. You recall a familiar image from physics class, ripples moving across a pond, calm, predictable, rising and falling in smooth patterns. One, and then you remember the other image, tiny particles like grains of sand bouncing around with crisp certainty. Down here, those two ideas quietly merge. A well-established scientific fact glides into view. Quantum objects, such as electrons, exhibit wave-particle duality, behaving like waves in some experiments and like particles in others. Reality, it seems, refuses to pick a single personality. You imagine a particle not as a dot, but as a spread-out presence, a rhythm, a vibration, a probability song humming through space. It doesn't travel from point A to point B so much as it resonates between possibilities. When unobserved, it behaves like a wave, flowing everywhere at once. When measured, it snaps into a particle, as if surprised you were paying attention. There's something almost theatrical about it. As though the universe is staging a performance, changing costumes depending on who's watching. A quirky tidbit floats by. In the famous double-slit experiment, particles sent one at a time still produce interference patterns, suggesting each particle somehow interferes with itself. One lonely particle, acting like it has company, the introvert's nightmare perhaps. You let that sink in slowly. A single object behaving as though it's in multiple places, overlapping with itself, creating patterns usually reserved for waves. It's strange, yes, but also oddly elegant. Instead of committing to one path, the universe explores all of them at once, only narrowing things down at the last possible moment. You begin to sense that this wave-like behavior isn't chaos, it's efficiency. Why choose one route when you can sample every option simultaneously? Why commit early when patience costs nothing? Historians still argue whether early physicists truly grasped how radical this idea was, or whether they initially treated wave-particle duality as a temporary mathematical trick rather than a statement about reality itself. As you drift, you notice how this dual nature echoes familiar experiences. You can be both tired and alert, focused and drifting. Here, now, you are listening, yet already halfway into sleep. Like a wave and a particle, you don't have to be just one thing. The universe seems comfortable with contradictions. It doesn't rush to resolve them. It lets waves be waves until they're needed as particles, and then quietly switches roles without explanation. No announcement, no apology. And you feel yourself settling into that same flexibility. There's no need to pin anything down tonight. Not thoughts, not meanings, not even yourself. You're allowed to exist as a gentle blur, spreading out, soft around the edges, like a wave that hasn't quite decided where it belongs. And as the boundaries continue to fade, you realize that solidity was never as solid as it seemed. Underneath everything, there's a rhythm, rising, falling, repeating, carrying you forward, one slow oscillation at a time. You drift onward, buoyed by waves that haven't quite decided what they are, when something subtle shifts. It feels less like movement and more like attention turning toward you. Not sharply, not accusingly, just a quiet sense that the universe has noticed you noticing it. This is where the observer's role begins to feel involved. Up in the everyday world, watching something doesn't usually change it. You look at a tree, and the tree carries on being a tree. Down here, that assumption dissolves. A well-known scientific fact settles gently into place. In quantum experiments, the act of measurement affects the system being measured, forcing a particle to take on a definite state. Observation isn't passive, it participates. You imagine peeking into a room and causing the furniture to rearrange itself simply because you looked. That's not far from how it feels. Before measurement, particles exist as overlapping possibilities, spread out like those gentle waves you've been floating through. But the moment they're observed, measured, recorded, interacted with, they collapse into a specific outcome. The universe, it seems, waits to be asked. You don't sense malice in this. No trickery, just a strange kind of responsiveness. As though reality is saying, tell me what you want to know, and I'll give you one answer, but only one. Everything else fades quietly away. The unchosen possibilities don't protest. They simply stop being relevant. There's a quirky story that drifts past you. Some early interpretations of quantum mechanics suggested that human consciousness itself was required to collapse these possibilities, as if the universe needed a mind-watching to decide what was real. It led to some wonderfully dramatic ideas about cosmic awareness and reality depending on eyeballs. Most physicists today don't take that literally, but the mystery lingered long enough to leave a faint echo. You notice how this feels uncomfortably intimate. The line between observer and observed blurs. You're not just watching the universe, you're part of the process that shapes what it becomes, moment by moment. Historians still argue whether the founders of quantum theory believed observation fundamentally creates reality, or whether it merely reveals one outcome among many that were always there. As you float, this idea softens rather than alarms you. Observation doesn't feel like control here. It feels like a gentle nudge, a quiet question asked of the universe. And the universe, polite as ever, answers once, then waits for the next question. You begin to see how this mirrors your inner world. The thoughts you pay attention to grow clearer. The ones you ignore fade into background noise. By noticing something, you give it shape. By letting it drift, you allow it to dissolve. In sleep itself works this way. Attention loosening, observation relaxing, possibilities narrowing into rest. You don't need to watch anything closely right now. In fact, you can let your observing soften, blur at the edges, like unfocused eyes in low light. Down here, nothing demands to be fixed into certainty unless you insist. So you ease back, allowing the universe to continue its quiet performance without your scrutiny. It will keep unfolding just fine. You've already asked enough questions for one night. Now, it's safe to simply let things be, unobserved, unmeasured, and beautifully unresolved. You drift a little farther, attention soft and unfocused, when the space around you begins to feel oddly connected, not crowded, just linked. Distances lose some of their meaning here, and things that seem far apart carry a quiet sense of familiarity, as though they've already been introduced when you weren't looking. This is where entanglement begins to make itself known. You picture two particles created together, like twins taking their first breath at the same instant. A calm, mainstream scientific fact settles in beside you. When particles interact, they can become quantum entangled, meaning their properties remain correlated no matter how far apart they later travel. Measure one and the other responds instantly. No delay, no message passing through space, just agreement. It feels almost intimate. These particles don't communicate in any normal sense. They simply share a single description, even when separated by vast distances. You could send one to the other side of the galaxy, and the connection would remain. Space stretches, but the relationship doesn't. The universe apparently keeps very good records. You imagine two dancers who learned a routine together and then performed it separately, perfectly synchronized, without music, without cues. Somehow, each always knows what the other is doing. It's eerie, yes, but also strangely tender, as if the universe values relationships as much as locations. There's a quirky detail that floats past like a half-remembered rumor. Albert Einstein once dismissed entanglement as spooky action at a distance, clearly unimpressed. He suspected there had to be a hidden explanation, something more sensible lurking underneath. Spooky was not a word he enjoyed attaching to physics, and yet the spookiness stubbornly refused to leave. On you sense that entanglement doesn't allow information to travel faster than light, no secret messages or cosmic texting. It's subtler than that. The outcomes are correlated, not controlled. Still, the fact that distance seems irrelevant at all feels like a quiet rebellion against common sense. Historians still argue whether entanglement reveals a deeply non-local universe, where separation is more illusion than fact, or whether it simply exposes limits in how we describe reality using classical ideas. Either way, the implication lingers. The universe may be far less fragmented than it appears. As you float, this idea begins to feel comforting rather than unsettling. Maybe nothing is truly isolated. Maybe separation is just a surface feature, like ripples on water that all belong to the same underlying ocean, even now. You're connected to the planet beneath you, to the air moving gently around your body, to distant stars whose light took years to reach your eyes. You notice how this connection doesn't demand effort. The particles don't work to stay entangled. They simply are. No maintenance required, no constant checking in. Just a quiet, persistent link that survives distance, silence, and time. You let that thought settle into you, slow and warm. Whatever feels far away right now, people, places, moments, you don't need to chase them. Some connections don't weaken with space, they just wait. And as you drift deeper, wrapped in this sense of cosmic togetherness, you allow yourself to rest inside it, held by a universe that, beneath all its strangeness, seems very good at keeping things connected. You continue drifting. When carried by invisible threads of connection, when the universe begins to feel playful again, less solemn, more experimental. Outcomes no longer line up neatly. Instead, they scatter gently, like dice rolling across a soft surface. This is where chance settles in, not as a flaw, but as a feature. Up above, you're used to thinking that if you knew everything, every force, every position, every speed, you could predict the future perfectly. Down here, that confidence quietly dissolves. A mainstream scientific fact eases into view. Quantum mechanics predicts outcomes probabilistically, and even with complete knowledge of a system's wave function, only the likelihood of results can be calculated, not the exact one that will occur. The universe, it seems, enjoys keeping a little mystery in reserve. You imagine the cosmos holding a pair of dice, rolling them endlessly, not recklessly, but with exquisite consistency. The odds never change, yet the results always surprise. Randomness here isn't chaos. It's structured, disciplined, almost elegant. Every possibility has a weight, a preference, a tendency. Nothing is equally likely, but nothing is guaranteed either. There's something strangely fair about that. No favoritism, no destiny carved too deeply in stone. Just a steady balance between freedom and rule following. You notice how this randomness doesn't feel threatening in your current, half-dreaming state. It feels permissive, like being allowed to wander without a map. A quirky tidbit drifts past you. Some physicists have compared quantum randomness to jazz improvisation, guided by rules, scales, and rhythms, yet never fully scripted. The universe knows the key it's playing in, one but not the exact notes it will choose next. Every performance is new, even if the structure stays the same. You begin to sense that this randomness isn't due to ignorance or missing information. It's not that the universe knows the answer and refuses to tell you. The answer genuinely doesn't exist until the moment arrives. Historians still argue whether this indeterminacy reflects a fundamental openness in reality itself, or whether hidden variables remain undiscovered, quietly determining outcomes behind the scenes. As you float, you notice how this idea mirrors life more than you might expect. You can plan, prepare, and predict, but outcomes still branch unexpectedly. Conversations drift, opportunities appear, sleep arrives when it feels like it, not when commanded, and somehow things still work out often enough to keep going. And you feel your muscles soften as you accept that you don't need to calculate anything right now. No need to predict the next thought, the next sensation, the next dream. Let the quantum dice roll without supervision. They've been doing this a long time. You breathe slowly, each breath a small surrender to chance. Inhale, possibility. Exhale, outcome. Neither needs your approval. The universe handles the details with quiet competence. And as you drift deeper into this probabilistic calm, you realize something soothing. Randomness doesn't mean instability. It means flexibility. It means there's room for rest, for surprise, for sleep to arrive naturally without being forced into existence. You drift onward, comfortably wrapped in chance and possibility, when something steadier begins to emerge beneath the randomness. It's subtle at first, when like noticing a rhythm in distant noise. The universe still feels strange, still unpredictable, but no longer unstructured. This is where you begin to sense that even the most flexible rules are still, in fact, rules. Down here, nothing behaves the way everyday intuition expects, yet nothing behaves arbitrarily either. A calm scientific fact settles into place. Quantum systems evolve according to precise mathematical equations, most famously, the Schrödinger equation, which governs how wave functions change over time. The outcomes may be uncertain, but the framework guiding them is remarkably strict. The universe bends, but it doesn't break. You imagine a river flowing through an unfamiliar landscape. The water swirls unpredictably, forming eddies and ripples, yet the riverbanks quietly guide its overall path. When quantum laws feel like those banks, firm enough to shape behavior, gentle enough to allow endless variation within them. Freedom and constraint coexist without complaint. This balance begins to feel reassuring. The universe isn't chaotic in the way a messy room is chaotic. It's more like weather, complex, sensitive, but still following deep patterns. You can't predict the exact path of a breeze, but you trust that air will keep moving according to rules older than memory. A quirky detail drifts by. Some physicists have described quantum rules as strangely conservative, noting that despite all their weirdness, they preserve quantities like energy with almost obsessive care. The universe may allow particles to exist in multiple states, but it keeps very tight books. No free lunches, no lost receipts. And you begin to sense that the weirdness of quantum mechanics comes not from a lack of rules, but from rules that don't care whether humans find them intuitive. They weren't designed to be understood. They simply are. Historians still argue whether the pioneers of quantum theory believed these laws reflected an ultimate truth about reality, or whether they were merely effective tools pointing toward something deeper and still unknown. As you float, this idea eases something in you. Structure doesn't require comprehension to be reliable. You don't need to understand every rule governing your body to trust it to breathe for you. You don't need to grasp every equation of the universe to let it hold you. You notice how this hidden order allows technology to function back in the waking world. Lasers, transistors, one and even the device playing this narration all rely on quantum rules behaving consistently. The strangeness is dependable, predictable in aggregate, trustworthy even when confusing. Your breathing slows, syncing with that underlying rhythm. There's comfort in knowing that beneath uncertainty lies something steady, something that has never failed to show up and do its job. The universe may roll dice, but it uses the same table every time. You let yourself rest against that idea, the sense that chaos is framed, that unpredictability lives inside boundaries that won't suddenly vanish. Whatever feels uncertain in your own life right now doesn't float in a void. It's held within quiet structures you don't have to manage. And as you drift deeper still, you allow the rules to keep running in the background, unseen and unbothered. While you slip gently towards sleep, you continue drifting, cradled by rules you don't need to understand, when something familiar begins to shimmer back into view. Not the everyday world itself, but the quiet way this strange quantum reality reaches up and touches it. The gap between abstract physics and ordinary life turns out to be thinner than it looks. You imagine the odd behaviors you've been floating through, waves, probabilities, restless motion, slipping quietly into practical use. A mainstream scientific fact settles beside you without fuss. Technologies like semiconductors, lasers, and magnetic resonance imaging all rely directly on quantum mechanics. This isn't just a theory living on chalkboards. It hums softly inside devices you use every day. Your phone, resting somewhere nearby, it depends on electrons behaving exactly the way quantum rules predict. Jumping between energy levels, tunneling through barriers they shouldn't cross according to classical logic. If quantum mechanics were only mostly right, modern technology would mostly fail, but it doesn't. It works with comforting reliability, even while remaining deeply weird underneath. There's something almost amusing about that. The universe can be wildly counterintuitive, yet still show up on time and perform as expected. A quirky detail drifts past you. The very same quantum tunneling that allows stars to shine also helps flash memory stored data. Cosmic fusion and cat videos, powered by the same underlying strangeness. You sense how quietly this happened. No announcement, no moment when humanity collectively agreed. Yes, when we are now living in a quantum-powered civilization. The transition was gradual, invisible. Quantum behavior slipped into infrastructure, medicine, communication, and computation, while most people carried on thinking of atoms as tiny solar systems. Historians still argue whether the inventors of early quantum technologies truly understood why their devices worked, or whether they trusted the mathematics long before they trusted the meaning behind it. In many cases, usefulness arrived well ahead of understanding. As you float, this begins to feel reassuring rather than unsettling. You don't need full comprehension to benefit from something reliable. You don't need to know how every part of your body works to let it heal, grow tired, and fall asleep. Trust, it seems, can precede explanation. You imagine quantum rules quietly doing their job beneath the surface of the world. Unseen, uncelebrated, but indispensable. They don't demand belief. They don't care whether anyone finds them elegant or absurd. They simply continue, moment after moment, making modern life possible. You feel a subtle gratitude for that steadiness, for a universe strange enough to be interesting, yet consistent enough to be dependable. The kind of balance that allows you to lie here, listening, without worrying whether reality will suddenly change its mind. As your breathing slows, you notice how this section of the journey feels closer to home, less abstract, more grounded. The quantum world isn't somewhere far away. It's stitched into everything you touch, including yourself. And with that realization, you let go of the need to separate the mysterious from the familiar. They've been working together all along, quietly supporting you as you drift closer to sleep, carried by physics that never asked to be understood, only trusted. You drift onward, gently carried by familiarity wrapped in mystery, when something you thought you understood begins to soften at the edges. Time, which usually marches forward with dependable rhythm, starts to feel less rigid here. Position, which normally feels fixed and reliable, becomes slightly negotiable. This is where sharp boundaries blur into something more forgiving. In the everyday world, you trust clocks and coordinates. You expect moments to follow one another cleanly and objects to occupy definite places. Down here, that confidence loosens, and a calm scientific fact settles into your awareness. Quantum mechanics places fundamental limits on how precisely certain pairs of properties, like position and momentum, can be known at the same time. The universe doesn't allow perfect sharpness everywhere at once. You imagine trying to focus on a single point in the dark. The harder you stare, the more the edges fade. Precision, it turns out, has a cost. To know exactly where something is, you must give up knowing exactly how it's moving. To pin down motion, you must let location blur. Reality trades clarity in one area for softness in another. This fuzziness doesn't feel like failure, it feels intentional. Like the universe prefers gradients over lines, transitions over borders. Time itself becomes less absolute here, less like a ticking metronome and more like a flowing experience. Events don't always line up neatly in cause and effect chains the way you expect. Some processes feel smeared across moments, happening not at an instant, but over a range. A quirky detail floats past you. In certain quantum experiments, particles appear to spend time in places they technically aren't allowed to be, as though briefly ignoring the usual rules about where and when things should exist. It's not rebellion. It's more like creative interpretation. You sense how comforting this softness can be. Sharp edges demand attention. Fuzzy ones invite rest. Just as your thoughts grow less precise as you drift towards sleep, the universe itself seems comfortable with ambiguity at its smallest scales. Historians still argue whether this uncertainty reflects an intrinsic blur in reality itself, or whether it arises from the way measurement disturbs what it tries to define. Either way, the effect is the same. The universe resists being fully pinned down. You notice how this mirrors your own experience right now. Time feels different when you're tired. Minutes stretch or vanish. Sensations blend. You're not fully awake, not fully asleep, occupying a soft in-between state that doesn't need clear labels. You allow yourself to rest in that fuzziness. There's no need to mark the exact moment you fall asleep. No need to locate yourself precisely in thought or space. Down here, precision is optional. As you drift deeper, time loosens its grip, edges dissolve, and certainty fades into something gentler. The universe seems to lean closer and whisper that it's okay not to be exact tonight. And some things work best when they're allowed to remain softly undefined. You continue drifting, suspended in that gentle blur where precision has loosened its hold, when the universe grows quieter. Not emptier, just more contemplative. This is the place where questions linger without rushing toward answers, where disagreement isn't a problem to solve, but a state to inhabit. The deeper you go, the more you sense that uncertainty isn't a temporary phase. It's part of the design. Even now, after more than a century of careful study, debate still hums softly around the meaning of everything you've encountered. A steady scientific fact settles beside you. While quantum mechanics is one of the most accurate theories ever developed, its interpretation, what the mathematics actually means about reality, remains unresolved. What the equations work beautifully, the explanations you politely disagree with one another. You imagine a group of thinkers sitting around a table that stretches across decades, each convinced they've found the right way to describe what's really happening. Some say all possibilities exist at once, branching endlessly. Others insist outcomes are decided but hidden. Still others shrug and suggest the question itself might be misplaced. The universe listens patiently, offering no clarification. There's something comforting about that silence. No final answer is demanded of you tonight. You're allowed to rest inside the not knowing. A quirky detail drifts past. One famous physicist reportedly kept a small sign in his office that read, "Shut up and calculate." A reminder that prediction works even when interpretation stalls. Understanding, it seems, is optional for functionality. You begin to sense that uncertainty here isn't a flaw. It's a buffer, a soft layer between rigid truth and lived experience. If everything were fully explained, pinned down, and settled, there would be no room left for curiosity, no space for wonder, no quiet mystery to drift through at the end of a long day. Historians still argue whether future discoveries will finally resolve these debates, revealing a single, clean picture of quantum reality, or whether uncertainty itself will remain an essential feature, something not to be eliminated, but accepted. Either way, the waiting continues, calm and unhurried. As you float, you notice how this mirrors life far above the quantum scale. Not every question finds an answer. Not every story closes neatly. Some uncertainties stay with you, not as burdens, but as companions. They soften expectations. They lower the volume on urgency. You feel the absence of pressure here. No demand to figure it all out. No test at the end. The universe doesn't seem concerned about being fully understood. It functions beautifully regardless, patient enough to let meaning arrive slowly or not at all. Your breathing deepens as you settle into that realization. It's okay to leave some things unresolved. Tonight doesn't require conclusions. It only asks that you drift gently inside a reality that doesn't rush explanations. And as you ease deeper into rest, you allow unanswered questions to fade into the background, like stars dimming at dawn, still there, just no longer asking for your attention. You drift onward, lighter now, as though the universe itself has slowed to match your breathing. The questions you pass through no longer tug at you. They rest where they belong, open, patient, unbothered. This final stretch doesn't introduce anything new. It simply lets everything you've encountered settle, like dust floating down after a long journey. You sense the shape of the universe not as a puzzle to solve, but as a place to inhabit. Probabilities hum softly. Waves rise and fall. Connections stretch without strain. Uncertainty doesn't feel like a problem anymore, it feels like atmosphere. Something you move through without noticing, something that supports you rather than threatens you. A final, steady scientific fact drifts by like a familiar landmark. Despite all its strangeness, quantum mechanics has never once failed an experimental test within its domain, not even a little. The universe may be odd, but it is remarkably consistent in its oddness. There's comfort in that reliability. Strangeness you can count on feels less frightening. You remember the idea from earlier, that certainty was never the foundation holding things together. It was probability, structure, and gentle rule following all along. That thought returns now, not as an idea, but as a feeling. A quiet confidence that things will keep working even when you're not watching. There's one last quirky notion that floats past, barely asking to be noticed. Some physicists half-jokingly suggest that the universe doesn't mind which interpretation you prefer, as long as you don't expect it to explain itself. Reality, apparently, has boundaries, and your understanding is one of them. And historians still argue whether future generations will look back on our current understanding of quantum reality as incomplete, naive, or surprisingly accurate. But that debate feels far away now. It belongs to alert minds, bright lights, and upright chairs. You're somewhere else entirely. You allow the universe to be exactly what it is: vast, subtle, unresolved, and you allow yourself to be exactly where you are. There's no need to chase clarity tonight. Sleep doesn't require answers, it only requires permission. Your thoughts slow, spacing themselves farther apart. Sensations soften. The last edges of wakefulness blur into something warm and indistinct. You don't mark the transition. You don't need to. And now, as promised, you ease into the wind down. The universe feels quieter here, not empty, just hushed. Like a room after everyone has gone to bed? The concepts you explored no longer feel like ideas. They feel like background music, fading gently note by note. Your breathing deepens, each inhale unhurried, each exhale a little longer than the last. You imagine yourself floating, supported without effort, held by patterns older than language. There's nothing to understand, nothing to remember. The universe continues its quiet work without supervision, and you are free to rest inside it. Time stretches, then loosens its grip. Thoughts drift past without forming sentences. Sensations dissolve into comfort. You don't need to follow anything anymore. Just drift, just rest. The universe will still be here when you wake.